Hello everyone, welcome to the very last video for the limits unit. I'm sure you guys are super upset. So for this video, I am just going to go through the unit review that's in the end of your homework packet, since no one's doing the homework packets, which is fine. I just figured this is the best way to kind of just cover a bunch of different problems all at once without making some totally brand new thing. Yeah, so then in class this week, we're just going to review, and we'll do a Kahoot, and then I'll post the test before class. And yeah, that'll be it for this unit. Alright, so this first chunk of questions, we're just looking at limits going to infinity, okay? So if we remember, we had our three rules that matched our asymptote rules. So for this first one, we just compare our degrees, right? So our degree on the top is just a 1. And our degree on the bottom is 2, so obviously our degree on the bottom is larger. And our rules tell us that if the degree on the denominator is larger than the degree on the numerator, our limit equals 0. Okay. Number 2, whoops, down here again, we're just comparing our degrees. So up top, our highest degree is 3, and in the bottom, our highest degree is 2. So when our numerator has a highest degree, that means our limit does not exist. Okay. Number 3, again, this is something that I stressed a lot in class, and in the video, so hopefully you guys remember this. When there's only an x on one side, that side automatically has the highest degree. So right here, our denominator automatically has a higher degree since there's no x up top to even compare it to. So our limit's going to equal 0. Number 4, this one's a little tricky. You got to make sure to look at it. So we have an x to the 5th here and an x to the 5th there. Polynomials may not always be in order when you are given them, like these two examples, so make sure you do identify your highest degree. Since they're both 5, that means we just do leading coefficient on top of leading coefficient. So we have negative 4/3. That negative could be with a 3, it doesn't matter, it's the same thing. Okay. Up to number 8. Again, since this is not written as a polynomial, we're going to have to distribute these x's in, okay? So this gives us 2x cubed. Distribute again, 2x to the 4th. Yeah, we don't care about those terms on the inside, right? We only care about our degrees. So this polynomial is going to be 2x to the 4th plus some other terms, okay? So we can compare. We have an x cubed and an x to the 4th. So our denominator is larger. So our limit's going to equal 0. Okay. Again, in this bottom, we have to distribute. This will give us an x squared. Right, so we have an x squared in the bottom and an x cubed up top. Okay. So our top is larger. This tells us that the limit does not exist. Okay. This one looks a little tricky, but I promise it's not. Coefficient in front of every x is just 1, right? And so since it's in the absolute value, that's just telling us it's guaranteed to be a positive 1, right? So we can go ahead and compare our degrees. They're both going to be 1. So we just do leading coefficient on top of leading coefficient. So it's just 1. It's going to be our limit. Okay. Number 11. This one, again, looks a little tricky, but hopefully you guys remember from class. We can just focus on our first term, our highest degree term. So x squared. And we can simplify this. The square root of x squared is just going to equal x. So now we can compare that to the 3x that we had, right? So these have the same degree, so we do leading coefficient divided by leading coefficient, so this limit is going to equal 1/3. Okay? So these are all the limits at infinity. Okay? There's going to be a few more on the next page, and then we'll start moving on to the algebraic limits and piecewise and all those things. Okay, we have a few more limits at infinity. So we got a 2x up top and then a cubed in the bottom. So since our bottom is bigger, that means our limit's going to equal 0. Okay. Number 6. Again, since we only have an x in the bottom and there is no x up top, by default, this denominator is going to have a higher exponent. Okay. So that means our limit's going to equal 0. Okay. Number 7, we're going to have to distribute our x's again. So this time, we got to be careful. We have a negative x right here. So when we distribute a negative x to a positive x, we have a negative x squared. Okay, so now we can go ahead and compare. So we have a negative x squared and a 2x squared. Since they have the same degree, we just do leading coefficient divided by leading coefficient. So this gives us negative 1/2. Okay. Now up to number 12. Okay. Again, we're going to have to distribute. So when we distribute on the top, again, this is a negative x squared. So we have negative x to the 4th plus some other terms. On the bottom, we distribute an x, and then we distribute again. So we'll have an x cubed plus some other terms. And when we go to compare those, we see that our numerator has a higher degree. So that means our limit does not exist. Okay? So 13, again, we're going to have to distribute. But this time it's a little trickier because we don't have, our coefficients are not all 1 in front of our x's when we're distributing, right? So we have a 3 and a 9, okay? So the way to know, since we actually have quadratics in this one, it's not just one x term, like we had over in 12 and number 7. Again, you're only going to distribute to the x term of the highest degree. All right, so this side, we're going to distribute 3x to 9x squared. That's going to give us 27x cubed plus some other terms. Okay. Now for this one, it's our negative 3x to our 2x squared. It's going to give us a negative 6x cubed plus some other terms. So when we compare these, they're both x cubes. So we're going to do leading coefficient divided by leading coefficient. So it's negative 27 over 6. And then we can clean that up a little bit, and that's actually going to be negative 9 over 2. Okay. All right, so for the last one, this one's actually a little tricky. So again, we have our square root. We can clean this up just looking at the square root of x to the 4th. Okay, that's going to give us x squared. Okay, but now in the bottom, we can't leave it like this, right? So we know that if we are to rewrite this, we have x plus 1 times x plus 1. And this we're totally familiar with. Okay, so again, we just distribute our x. So we have an x squared in the bottom plus some terms. So now let me just go ahead and rewrite this. Remember, this was our numerator. So we have x squared plus some stuff, whatever this is going to give us. And then the denominator, we again have x squared plus some stuff. Okay, so now we can compare. These are both x squareds. So it's just leading coefficient divided by leading coefficient. Since both of them are 1, our limit is going to equal 1. Okay, so that is that on limits at infinity. Now we're going to move on to solving limits algebraically. Okay, so remember our 3 methods were factoring, rationalizing, as well as just substitution. Right, so the first thing we want to do is we want to substitute if possible. So when we go ahead and we substitute in here, we end up with 2 times 1 divided by 1 plus 1. Alright, so we have a 2 on the top and a 2 on the bottom. So our limit just equals 1. Okay. Always going to be our first step is substitution. Okay. So, number 16. Go ahead and substitute as well. So we'll have a negative 2 minus 2 divided by 2 squared plus 2 times 2 plus 2. That's a whole lot of 2's. Okay. So when we clean this up, we get a negative 4 up top and a negative 10, or a positive 10 in the bottom. Except we can simplify this fraction even more. This equals negative 2 over 5. Okay, obviously both are acceptable. They're the same answer. Okay. On to number 17. Now this is when we're going to have to start factoring. Okay, can't just substitute, because if we were to substitute, the issue that we'd run into is we'd be dividing by 0. Okay. And so when we divide by 0, that does not equal 0. It's undefined, right? So our limit would not exist. However, we have these factoring tricks and rationalizing tricks that do allow us to carry on and move forward. So first thing we need to do, and it's important to be really, really careful with your limit notation. You only drop your notation when you have no x's left. So we can rewrite this as the limit as x approaches 3. Up top, we can take out a 2x. Then we're left with x minus 3. In the bottom, we still have x minus 3. Okay. So now what we can do, we can go ahead and cross off these x minus 3 terms. just like when we have wholes, right? And again, really important to only cross these things off when they're being multiplied. Okay, so since the top two terms are being multiplied together, that means that we are allowed to cross off these terms. Okay. If this was like a plus x minus 3, then you wouldn't be able to cross them off. Okay. So we're just left with the 2x, and so then we can go ahead and substitute it in. We have 2 times 3, so our limit equals 6. Okay. Number 18, again, we're going to factor, so we have the limit as x approaches 1. Top is going to factor as x plus 1, x minus 1, okay, divided by x minus 1. Again, you can go ahead and cross off these x minus 1s. So now, when we substitute in, we just have 1 plus 1, which equals 2. Okay. The whole point of factoring is to kind of just clean up this whole situation and make these functions a lot more manageable and a lot easier to work with. Okay, so, oops, sorry. Gotta clean up my desk a little bit. I got too many pens around, okay? All right, number 19, we can go ahead and factor. So, the limit, as x approaches 4, up top we still have x minus 4. The bottom is going to factor x minus 4, x plus 3. Okay, so now we can go ahead and cross off our x minus 4s. So we're just left with the limit as x approaches 4 of 1 over x plus 3. Okay, so now we can substitute. We have 1 over 4 plus 3, so our limit equals 1/7. Okay. So that's it on factoring. Now we're going to get into rationalizing, which, again, I know was a little tough when we were doing it in class, so hopefully after rewatching the videos and doing the homeworks, it's a little easier to work with now. But the whole point of rationalizing is to get rid of dividing by 0, just like we did with factoring. That's our whole problem, right? Is dividing by 0, because that creates a lot of issues. So when we rationalize, what we do is we multiply by the conjugate of whatever part that has our radical. So our conjugate, we're just changing that sign in the middle. So for number 20, what we're going to multiply by on the top and the bottom is going to be 1 plus the square root of 1 minus x. Okay, 1 plus the square root of 1 minus x. Right, so notice how the only thing that changed is that middle sign, right? We didn't change the sign on the square root at all. Okay, so what we do, now we are going to go ahead and multiply them. So top, I always say leave it as is. So whatever, if you're not multiplying the two square roots together, leave it how it is, okay? Because things are going to cancel. So this gives us the limit as x approaches 0. Up top, we just have x times 1 plus the square root of 1 minus x. Okay. In the bottom, if you guys remember, the really cool thing about multiplying conjugates is that our middle terms are always going to cross off. So we only have to be focused on multiplying our first two terms together and our last two terms together. Okay, so we just have 1 times 1, which is 1. And then when we multiply our square roots, the square root goes away. And then make sure to be really careful. We do have this negative, so everything under the square root is going to become negative. So it's a negative 1. Negative x gives us a positive x. Okay, so as we can see, these 1s are going to cancel, right? And then we have an x on the top and the bottom that we can also cross off. Okay, so we're just left with the limit as x approaches 0 of 1 plus the square root of 1 minus x. So now we can go ahead and substitute. And luckily we're substituting in 0, so that's super quick and easy. We're just going to be left with 1 plus the square root of 1, which is just 1. So we're going to have 1 plus 1, that equals 2. Okay, rationalizing can be tricky at first, but hopefully at this point in the unit, it's not too tricky, since this is now technically week 5. But yeah, on to the next one. So again, we need to multiply by our conjugate. Our conjugate here is going to be 2 plus the square root of 4 minus x, top and bottom. Okay? So, again, like I said, when we have our square, when we're multiplying the conjugates, we only care about our first two terms and our last two terms. Okay, so this gives us the limit as x approaches 0. 2 times 2 is 4. Now we need to drop our square roots, and again, everything's going to be negative under that square root. It's going to be minus 4 plus x. Okay, our denominator, we're going to leave it as x times 2 plus the square root of 4 minus x. Okay, now if we take a look, up top we have 4 minus 4. That goes away. And then we have these two x's, which we can go ahead and cross off as well. So we're just left with the limit as x approaches 0 of 1 over 2 plus the square root of 4 minus x. So then when we substitute in, we're left with 2 plus the square root of 4, which is just 2. So 2 plus 2 in our denominator tells us our limit is going to equal 1 over 4. Okay. Right. On to the next one. Right. So these are a little tedious, but not too bad. We're going to multiply by our conjugate. So we have 1 plus the square root of x squared plus 1, top and bottom. Right. Again, just our first and our last terms. So the ones in the square roots. So we're left with the limit as x approaches 0 of 1 minus x squared minus 1, all divided by x squared times 1 plus the square root of x squared plus 1. Okay. So, again, we have this plus 1 and a minus 1. Those cancel. Now this one's a little different. We do have x squareds on the top and bottom, so we can cross those off. But since this was a negative, we're going to be left with a negative 1 on top. Okay. So this gives us the limit as x approaches 0 of negative 1 divided by 1 plus the square root of x squared plus 1. And again, since this is just 0, just like the one up top, when you plug in 0, you just get the square root of 1. So we have 1 plus 1. So our limit is going to equal negative 1 over 2. Okay, right? Because when you plug in that 0, you just get the square root of 1. So the square root of 1 plus 1 equals 2. All right. On to the last section. So we have a few more factoring, rationalizing examples, and then we're going to go into looking at them from a graph. Okay, so first one. This is just kind of a nice summary, actually, of the 3 different methods, because first up, we just have substitution, right? Since there's no fraction, nothing like that, we can just go ahead and substitute immediately, right? That should be a nice little giveaway. So when we substitute in, we have 5 times 2 minus 4. 10 minus 4 is going to equal 6. Okay. So now, on to number 24. We're going to go ahead and factor. That top is going to factor. Oops, let me keep my limit notation. The top is going to factor as x plus 7 and x minus 1. Our denominator stays as x minus 1. Okay. We can cross off those x minus 1s. So we're just left with x plus 7. Okay. And so then when we substitute in, we're just going to have 1 plus 7. So our limit equals 8. Okay. Now, in our last example for rationalizing, again, got to multiply by our conjugate. So our conjugate for this one is going to be the square root of x plus 9 plus 3. Okay. X plus 9 plus 3. So when we distribute, again, only first and last terms that matter. So we have the limit as x approaches 0 of x plus 9. Negative 3 times 3 gives us negative 9. Our bottom stays as x times the square root of x plus 9 plus 3. Okay. So we have positive 9 minus 9. That goes away. And then we have the two x's. Those also cancel. So we're just going to be left with the limit as x approaches 0 of 1 over the square root of x plus 9 plus 3. And so when you substitute that in, you plug in 0, so you have the square root of 9, which is 3, plus 3, gives us 6 in our denominator, so our limit equals 1, 6. Okay, so that's it on like the week 2 material. Now we're backtracking and going to graphing. Okay, so there we go. All right, so first thing we want to do is we want to find our y value. So f of -4, you just go over to -4. We see that there's an asymptote, so that tells us this value does not exist. Okay. Now we need to find our limit from the left. We approach -4 from the left. We see this is going up towards positive infinity. Now we need to approach -4 from the right. When we do that, that's going down to -2. And so lastly, we need to compare. Our left limit equals infinity, our right limit equals -2. Since those are not the same value at all, that tells us that our limit as x approaches 4 of this function does not exist. Okay, on to the next row. Number 30, we're looking at x equals -2. So if we look, go to -2, there's an open circle. There's no closed circle anywhere else, so this again tells us our function value does not exist. Okay. Now I need to look at our limit from the left. That takes us to 1. Our limit from the right also takes us to 1. So this is a good sign. Our left and our right limits are equal. So this means our limit of this function as x approaches -2 equals 1. Okay. Lastly, we're looking when x equals 1. So f of 1, we have our closed circle, that equals 1. Approaching 1 from the left, that takes us down to -3. Approaching 1 from the right, that takes us to 1. And so lastly, we just want to find our limit. Since our left-hand limit and our right-hand limit are not the same value, this tells us that our limit does not exist. Okay? So, last thing we're going to talk about is these 2 examples on continuity. Okay, so remember, we have our 3 steps. So, first step, we want to find f of 1. Okay, so again, that's going to use this function right here. When we plug in 1, we have 1 plus 1 squared. That's just going to equal 2. Okay. Next step is we need to find our limit. And so since we have our restrictions as inequalities, we have to use both functions as our limit to find our limit. So we have to do the left and the right hand side. So the limit as x approaches 1 from the left, we're going to use our top function, so 1 plus x squared. We need to also find the limit as x approaches 1 from the right. We're going to use this bottom function, -x plus 3. And so when we substitute 1 up here, we get 1 plus 1 squared, again equaling 2. When we substitute 1 down here, we get -1 plus 3, which gives us 2. So this tells us, since these are the same value, that our limit as x approaches 1 of f of x equals 2. Okay. So now we can go to our third step, and that's just checking. Does our f of a value, which is 2, does that equal our limit, which is 2? And so yes, 2 equals 2. Therefore, our function is continuous. Okay. Last example, still continuity. So first step, f of 1. Okay. Notice this piecewise has a different type of restriction, domain restriction. We're written using x equals 1 and x does not equal 1. So for f of 1, our answer is already given to us. It's going to equal 5. Okay. Next step is we need to find our limit. This one is going to be a little different than last time. We are not going to have to find our limit from both sides, since our domain restriction is like this, right? Because all of our left-hand values and right-hand values are written right here. Another way of writing x does not equal 1 is to say x is less than 1 and x is greater than 1. So these would be our left limit and our right limit, but they have the exact same function. So that's why you don't have to do both sides. Okay, so we're just going to use x cubed. And we just go ahead and substitute in. When we substitute, we just get 1. So our last step is to check, does our f of 1, which is 5, does that equal our limit, which is 1? Those are not equal. Okay, so this tells us that this function is discontinuous. Okay, and that is it for the review. Hopefully this was really helpful and you guys do really well on the test. Again, I'll post it. It's going to be a Google form. We will review in class, so you can email me any questions, ask any questions in class, come to office hours on Wednesday or Friday if you still have questions after class. And yeah, good luck. Make sure to watch any old Edpuzzle videos or submit any old homeworks that you have not submitted thus far. And good luck!